Guys, so this is the third and final video of section 12.4. And in fact, this is the last video of the matrix chapter. Okay, and so we're just going to apply what we've been doing into a word problem. Okay, so let's read this. It says that a large pizza at, I don't know, whatever that is, pizzeria cost $6.80 plus 90 cents for each topping. So $6.80 plus 90 cents per topping. Okay, and that gives me the price of the pizza. And I'm going to put P1 because it's the price of the pizza at this store. Okay, because we're going to have another pizza store too. So the cost of a large pizza at the other pizza store, okay, is going to be $7.30 plus 65 cents for each topping. And I'm going to write P sub 2 for the price of the second pizza. So how many toppings need to be added to a large cheese pizza from each store in order for the pizzas to cost the same? Okay, well, if we want the pizzas to cost the same, guys, we know that P1 is equal to P2. So I'm just going to make both of these P's because they cost the same. So just use a variable. Okay, so from here, we want to set up some matrices, okay, to solve for this system. So in order to do that, I'm going to rewrite these. Okay, remember, we want the constant to be on the right, the variables to be on the left. Okay, so I can just rewrite this as 0.9t minus p equals negative 6.8. And I can rewrite this as 0.65t minus p equals 7.3. All right, so now that I have my two equations, I can set up my coefficiency matrix. So I have 0.9 and negative 1. And then I have 0.65 and negative 1. And my two variables here are, what are they? T and P. And you could make it X and Y, whatever you want. Okay, and I know that's going to equal negative 6.8 and this should be a negative 7.3. Negative 7.3. Okay, so now I've set up my matrix. All right, so first thing we want to do is we want to find, if this is A, we want to find my inverse of A. Okay, so I find that by doing 1 over the determinant, got ahead of myself here, 1 over the determinant, so negative 1 times 0.9 minus negative 1 times 0.65, and multiplying it by, I'm going to flip the order of these two, or flip the places, 0.9, and then I'm going to flip the signs of these, so 1, negative 0.65. Okay, well, this is just 1 over negative 0.9 plus 0.65. Negative 1, negative 0.65, 0.9. All right, which is 1 over negative 0.9 plus 65 is negative 0.25. 1, 1, 0.65, 0.1. Okay, now, just to clarify where this is coming from, this here is the same as 1 over negative 1/4. 0.25 is 1/4. Okay, so remember when we divide by a fraction, it's the same as multiplying by the reciprocal. So it's the same thing as saying 1 times negative 4 over 1, which is just negative 4. Okay, so this here is negative 4. So I'm going to write this as negative 4, negative 1, 1, uh, negative 0.65 and 0.5, which then gives me positive 4, negative 4. 4 times negative 4 times negative 0.65 gives me a positive 2.6, and a negative 4 times a positive 0.9 gives me a negative 3.6. Okay, so this then is the inverse matrix of A. Okay, so now I'm going to take this matrix and I'm going to multiply it on both sides of the equation. Okay, so we have my 4, negative 2.6, negative 3.6 times 0.9, negative 1, 0.65, 0.65, and negative 1 times my t and my p, and that's going to equal 4, 4, 2.6, 3.6 times my negative 6.8 and negative 7.3. I ran out of room there, guys. All right, so as a reminder, this is my identity matrix. So 1, 0, 0, 1. Then I'm left with T and P. Okay, that's going to equal. Okay, so this is going to be 4 times negative 6.8 plus 2 times negative 7.3. Oh, sorry, 4 times negative 4 times negative 7.3. Okay, and this here is going to be 2.6 times negative 6.8 plus negative 3.6 times negative 7.3. Well, guys, this here, when I multiply by the identity matrix, it's just itself. So this is just my TP equals. And then from here, I get, if I put all this into my calculator, guys, I get 2 and 8.6. Okay, so to interpret what this means, my T is 2, so when 2 toppings are added, my price, the price of each pizza is $8.60. That's a wrap.